Let's continue our study of chemical equations, getting our final basic type of chemical reaction, the double replacement reaction. At this point, we've covered synthesis, decomposition, and single replacement, and now, in terms of general types of chemical reactions, we have the double replacement reaction. The double replacement reaction has two ions that switch places, hence the term double replacement. You have an ionic compound containing an anion and a cation, and it reacts with another ionic compound. The cation will bond with the anion of the other compound, and then this cation and this anion will bond. So you have two compounds forming two new compounds. So here you've got silver nitrate. The silver will react with the chloride on the other compound, and the potassium will react with the nitrate to form two new compounds. So when you have the typical double replacement format, compound plus compound yields two new compounds. Basically, the cations and or anions switch places. But there has to be a reason for them to switch. You're not going to get a double replacement reaction to occur if these two compounds are stable in and of themselves. So let's look at the formation of a precipitate, which is one driving force for double replacement. So we've got our compound here, AB, and we're reacting it with this new compound, CD. When you put the compounds in water solutions, the water, if both compounds are soluble, will pull the ions apart, and then you'll have all four ions randomly floating around in solution colliding with each other. If the ions collide back in their original compounds, which were soluble, then the water will simply pull them back apart again, and they'll continue to float around, and no reaction will have occurred. If, in the process of colliding, the two cations collide and the two anions collide, since positive and negative ions will not hold together or form an attractive force, the water will simply pull these back apart, and again they'll go along their way of randomly colliding in the solution. If you get two of your ions to sort of switch places, so as you are colliding, you have a collision between the two different cations and anions, and if one of these happens to be insoluble so that the water cannot pull it apart, then that will form a new compound that is insoluble. And being insoluble, this stops water from being able to pull all four ions apart, where they would just continue their random collisions. So if this insoluble product forms and settles to the bottom, then the reaction is said to have occurred. The identity of this substance is a precipitate and insoluble ionic compound. In order for a double replacement reaction to occur by random collisions of ions, you have to form one of two substances that's insoluble. Either you form a gas, so if something collides, makes a product that forms a gas that bubbles out, or, very commonly, you form an insoluble substance that settles to the bottom and forms a precipitate. So one of these two things must occur for a double replacement reaction to happen. Looking at this, it certainly fits the pattern of double replacement, two compounds. Take your silver nitrate and your potassium chloride, throw them into water solution, and you've got your four ions randomly again colliding. If in the process of collision, when you look at the new product formed, you're going to have this cation and this anion, and you're going to have this cation and this polyatomic anion. If one of these products is insoluble, as silver chloride is, and settles to the bottom, then your reaction has produced a new product and the double replacement reaction has occurred. When you're writing this, make sure that you write all your ions and then go back and balance if necessary. This reaction needs no balancing. The reason that it occurred is because the solid, insoluble silver chloride precipitate, again abbreviated PPT, has formed, driving the reaction to completion. When you're deciding if a compound is soluble, you use some simple solubility rules, and we'll practice these in class. Any compound containing sodium ion or potassium ion or ammonium ion will be soluble. So if you have this compound formed, you know that it cannot be the precipitate. This could be a precipitate, and we'll see the rule for that shortly. If your salt contains the nitrate ion, it is also not going to be the precipitate. All salts containing the nitrate ion are soluble. So this salt would be soluble because of the potassium rule and the nitrate rule. This salt would also be soluble because of the nitrate rule. Chloride ion, all chloride salts are soluble, but there are a few exceptions. Silver chloride, lead 2 chloride, and mercury chloride. So this, following the pattern of an insoluble chloride, such as mercury and lead and silver. All sulfates are soluble, except for a few: barium sulfate, lead sulfate, and calcium sulfate. So if you saw a compound like sodium sulfate, you would know that this was a soluble compound because it is not one of the exceptions to the sulfates, and basically because all sodium is soluble. Don't worry, we'll practice these solubility rules enough in class so that you will become very comfortable with them. Let's look at an example reaction to look at your thinking processes in this type of reaction. Two compounds in solution being mixed, double replacement format. Go ahead, write your new compounds: sodium nitrate, NaNO3, and silver chloride. You can see that a precipitate has indeed occurred and that its identity is silver chloride based on the insoluble chloride rule. Sodium nitrate, all sodium, all nitrate compounds are soluble. This compound is present. It is simply in solution. It is not in ion form. So once you have decided on the reaction occurring, you then go forward, write, and balance the equation. In this next reaction, you have lead 2 nitrate. So write your formula: Pb NO3 2 reacting with potassium iodide. Your format would make you lead 2 iodide and potassium nitrate. Before you balance, you want to make sure that the reaction actually occurs. You can see evidence of this yellow precipitate, so the reaction occurred. The next level is to identify this precipitate. It has to be the lead 2 iodide because all potassium and all nitrate compounds are soluble. Once you're sure the reaction does occur, then take the time to go back and balance the reaction. Another format of double replacement reaction that's quite similar is an acid-base reaction, or commonly called neutralization. An acid and a base will always react to form a salt and water. The format of these reactions is very similar to double replacement. If we use hydrochloric acid and sodium hydroxide and we follow the double replacement, we're going to get HOH, which is water, and the salt that would be formed is sodium chloride. So the formatting is very similar to double replacement, but they are classified as neutralization if the two compounds that react are acids and bases. Again, acid-base reaction, salt and water produced, and balance the equation if necessary. When we're talking about salts, again, Nitric acid is an acid, lithium hydroxide is a base. The salt in this case is going to be lithium nitrate. Salt simply meaning an ionic compound. Then, of course, you also get water as your product, and the equation is balanced. So neutralization reactions involve acids and bases. The formatting is very similar to double replacement. You make a salt and water. Make sure you take some time to memorize the common acid formulas: hydrochloric, sulfuric, nitric, acetic, phosphoric, and carbonic acid. This will allow you to recognize these acids when they react with common bases. So double replacement and acid-base formulas, very simple and very similar to each other.